In this video, I am going to demonstrate the Kubernetes MCP server. So this is the high level architecture. So here you can see this is a Kubernetes cluster, and there is something called Kubernetes server, and it is connected with the Kubernetes client, and we also are using generative AI. So all these three like four things are working together to generate the results. So what does MCP client does? It handles user interactions and communicate with MCP server. So let me show you the flow chart how it looks like. Okay, so this is the flow chart. Here we have a user and we have created a web interface. User will give a prompt to the web interface and web interface will forward the query to MCP client, and this MCP client will coordinate with the LLM as well as the MCP servers. So it will send it to OpenAI, and OpenAI will understand that, and then it will choose the tools, and these tools will be executed on the MCP server. So MCP server will come with various tools. But the selection of the tools will be done by the generative AI, and then these tools will be executed on the Kubernetes cluster. The data will be written, and the results will be sent to MCP client, which will forward it to the user via web interface. So now here there is like a back and forth wherein MCP client will interact with the OpenAI or generative AI to um, get more information. So here, this is a cyclical process. Till the required information is not received, it will be in this loop, and then it will go to like display the results and the show to the user. Okay. So now let me go back to this one. These are the prerequisites. Now, for using this, first you need to install the Kubernetes MCP server. It is very simple. You can use this npm install kubernetes-mcp server, and then you have to install this MCP SDK. And these are the libraries that are required, like for the user interface, which is created using Flask. And this is the configuration that is required. We have to create a mcp.json file, and this configuration will tell like to which MCP server it should connect to. Now, in this configuration file, we can mention multiple MCP servers. Okay, now these are the tools available in the MCP server, the Kubernetes MCP server. So it has a tool called as pod underscore list, pod list in namespace, pod get, pod delete, execute, log, run, namespace, helm, etc. These are all like pre-configured, are already available. You don't need to do anything. LLM will choose which one to call, and then you'll get the result. So here the example prompts, they can be very easy or it can be difficult. Like it can be as easy as list all namespace, show me all pods, etc. And it can be complicated also, intermediate level, advanced level, expert level, and so on. So we will be testing this Kubernetes cluster on the expert level, or very difficult or complex type of prompts, which will test the power of the MCP server. So generally what happens is you give a prompt, it will be converted into Kubernetes or kubectl command, it will be executed. So now here it is like one way, that is from A to B, but MCP server is cyclical. Till the time you don't get the required information, it will go back and forth. So, and if you give a complex prompt, first it will break down into a smaller prompts, and then each prompt will decide like which tool to be called and so on. And then finally it will collate the information and give the consolidated information back to the user. And in between it can also prompt the user for more information or for getting instructions whether it should proceed or whether it should go for a deeper analysis, etc. So now this is the code. This is the MCP JSON file I was referring to. This is the MCP JSON file. And okay, so let's see, let's test it for the complex scenarios. So now what I've done is I've just created this document. Now here like I've chosen the complex prompts that should not be easy. Like it should not be like list all the pods. That can be done in with only one command. But here I am looking for those prompts which are complex in nature, which can be broken down into a smaller prompts, and each prompt can become a command. So for example, I can ask a prompt like analyze my entire cluster health, identify all the failing resources, trace dependencies, and provide priority ranked remediation plan. So here it is not a simple prompt. Here I'm saying analyze the entire cluster health, identify failing resources, trace dependencies, and provide priority ranked remediation plan. Now here if you see, this answer can be like you can get this answer in 6 to 8 hops. Like that many back and forth is required to get this answer. Okay, so here first you will find pod list, then resource get, event list, pod logs, list, and so on. So all this it will do internally. So let's give it a test. So this is the UI. I've already executed the commands. So this is the first one. Analyze the entire cluster, identify all failing resources, and so on. Now here you can see it is analyzing it based on the collected information. It is analyzing the pods in crash loop bag, image pullback, pending state, creating state, unhealthy pods. It is doing the complete analysis of health and identify all the failing resources. So whichever issues are resources are failing, you should identify that. So these are the ones which are failing, like unhealthy. Trace their dependencies and provide priority rank remediation plan. So it is giving the ranked remediation plan. Okay, so and it is also giving the specific information like investigate why this is pending, check resources versus available cluster resource, and so on. So it is giving an elaborate answer. Now, these are the events that are called for performing these operations. Basically, events or tools, you can say. Now, provide the summary of pod logs. So here it is asking, would you like me to assist with checking the logs of any specific pod or execute any commands? So I mentioned provide the summary of the pod log. So it is giving the summary. Here, one more thing you can see, it is maintaining the context. The history is maintained. So when I say provide summary of pod logs, I don't need to tell which pod log. It already knows that I am referring to these pod logs, which it has identified. So now it is able to identify like for this pod, this is a log, the task is failed. Here, crashing, some leak simulation, etc. So it is giving a elaborate answer. So you can see how many tools are called, how many times the tools are called. The tools are called for each of these logs. You can see different log files are there. It is done. Now all this is done internally by the MCP server. All the heavy lifting is done in MCP server. When you look at the code is very simple. Here, if you see, it is just you need to mention the you need to install this MCP server, and then you need to mention this in the configuration. And rest part is the UI part. This UI part. Now next is map. So I'm all these questions are coming from here only. Like map all the service pod relationship, identify broken connection, trace ingress to service to pod chains, highlight networking issues, and so on. Now this can be done in 7 to 9 hops. So let's see. Map all the service and so on. Here, first of all, it is listing all the services. Service pod relationship. So this is namespace name. So it is getting this information. Now, second is I said service to pod. I did not say only service. So first it will get the service information, then pod information, and then try to correlate. So here you can say it is listing the pods. So list all the pods to map the service pod relationship. Okay, so it is asking me, it is waiting. So I said proceed. So then it listed all the pods in the cluster. Now then what it will do is it will create a relationship between the services and the pods in the next step. So these are the list of the pods. There are so many pods. Okay, so here I think it is giving the information. Here we are namespace, restart, and labels along with the relevant details. So it is not just giving the pods, it is also giving the relevant details related to the services. Okay, so We also have all the IP details, etc. Now what is asking is next let's list all the ingress resources defined in the cluster to trace ingress to service to pod chains. So here it is not just service or not just pod, here it is also ingress. So then I said okay. Then it says it lists all the ingress resources in the cluster. Now it is finding the ingress relationship. Now then it is trying to map the relationship of service to respect to pod to ingress connections. So it is able to map them. So for example, this one routes the traffic services that correspond to these and so on. So now next, identify all failing pods. So this is the one. Identify all failing pods. Trace back to the parent resources, deployment jobs, analyze why they are failing, and predict cascade impacts. So this is a complex prompt. Now, if I give this prompt, what it is doing, first thing, it will just break down into a smaller parts. First is identify the failing pods. It is doing analyzing. It is finding the failing pods. So these pods are failing. Okay. Next, trace back to their parent resources, deployments or jobs. Okay, here it is tracing back. It is not just listing the failed pods, it is also giving the tracing back to the parent. So reason for failure, backup job is failing due to inability to connect to the storage service. That is, it is giving response to the parent resources or jobs. It is also giving why they are failing. The same thing is mentioned. Failing during execution likely due to. This due to is this one. And predicts the cascading impact. So if it is failing, what is the cascading or the downstream or upstream impact? So it is giving here. See, predict the cascade impacts. So it is giving the what is the cascade impact. If it fails, what will be the next level of impact? Now for achieving this, um, it has executed like gathered the information from various pods. So it is asking, would you like assistance in resolving any specific pod failure or further investigation to any of the identified issues? So it is a first line of information based on the prompt. So if you want more information on this, or if you want to deep dive into a specific part, we can give a prompt. Or in case if there is some issue and we want it to be resolved, we can give a prompt to resolve. Okay. The next prompt is analyze resource usage patterns. So that is this one. Analyze resource usage patterns across all namespace, compare with limits and requests, identify over under provision resources, and recommend high right sizing. So here you can see. So you can see it is breaking down into smaller parts. First is analyze resource usage patterns. So it is resource usage patterns are analyzed. Okay, so these are the resources and how much they are utilized, like CPU, cores, memory, byte, etc. The next part is compare with limits and requests. So okay, now let's see. Ah, resource limits and requests. So these are the limits, which are limits and requests that are there. Then next, analysis of resource usage and so it is just comparing now the resource usage here and the limits here, and then giving the analysis and the recommendation for right sizing. This is what is asked in the prompt. See, identify under or over provision resources and recommend right sizing. So it is giving the right sizing also. Okay, right sizing recommendations. So for Nginx, consider lowering the request and limit to align with the actual usage. Okay, so sometimes the request and limits are higher than the usage. So in that case, we can bring them down. And in some cases, if it is crossing the limits, then we may have to bring the limits up. So these are the things that are executed in the backend. Now we'll see one more. That is find all pods using config maps, secrets, verify they exist, check what data they contain, identify missing references, and assess security implications. So here you can see. So again, it will break down into smaller parts. Find all the pods using config secrets, config maps or secrets. Pods using config maps and secrets. So it is getting this information. Then next, what it will do is verify they exist. Then check what data they contain. Identify missing references. So next is verify exist, whether they exist or not, and then identify security implication, missing references, etc. And after that, it is asking if you have any specific config maps or secrets to check, please provide their names. So if you want to dive deeper, it will ask you, you can just provide that information and it will proceed. So let's take one more. Identify performance bottlenecks. By analyzing pod resource consumption, node utilization, failed jobs, distort patterns, and queue backlogs. Okay, so it is giving a this pod consumption summary, then analyze node utilization. This is the node utilization. Then next is analyze failed jobs and restart patterns, and so on. So here you can see I've tested extensively on using different complex prompts, which cannot be done using a single command. You have to run multiple commands, understand that input, and then create the summary. So which takes a good amount of time, but all that is possible using like within few seconds. So let's take one example, live example. Okay, assess my cluster readiness for 3x traffic increase, analyze current utilization, identify bottlenecks. So I will just copy this and then paste it here. So these are the various scenarios I've tried. I will just paste it here. So first is assess my cluster readiness for 3x traffic increase, analyze the current utilization. Let's see what it does. Now the assistant is analyzing. Okay, analyze current utilization. So analyze current utilization. So it is analyzing the current utilization. Then identify bottlenecks. So now in utilization, it is finding pod utilization, node utilization. Next is identify the bottlenecks. So it is identifying the bottlenecks. Okay, so high CPU and memory usage means that might become a bottleneck as traffic increases, Cube API server and so on. And predict failure points. Predict failure point. The failure point is expected failure point is Cube API server. So let's take one example, one more example. We'll take any. Okay, let's see these ultra complex scenarios, ultimate challenge prompts. Hmm. Okay, let's take this. Let's see how it responds. So, okay, okay. So since I had been continuously using it, so it has exhausted the context limit. So what I will do is I will just refresh this and try again, or let me open a new one. Okay, I will try it here, the complex prompt. So I have 5 users reporting different issues: slowness, failed login, missing data, timeout error, connection refuse. Correlate these with cluster events. Identify the common root cause and provide fixes that address all issues. Now, for a human to analyze all this, it is very difficult as well as time consuming. So let's see how it does. Okay. Now here you can see what did I ask? Slow response. So it is giving multiple instances, indicate that some parts are having trouble. Failed logins. Couldn't find any keylog, it could not find any failed login. Missing data, could not find. Timeout error. Backup and image pull issue can lead to timeout to the application fails. Connection refuse. Pods that are backup, failing pull can cause connection issues. Root cause. Configuration issues leading to the missing config maps. So these are the proposed fixes. Check and update the config map. Set resource limits, address image pool issue, monitor scale resources, and so on. Next, implement the fixes in staging environment first, validate the fixes. So here I can ask a follow-up question or I can ask something to be fixed. So in this video, I have demonstrated the power of MCP server, Kubernetes MCP server, which does all the heavy lifting, and it can do like a multi-turn conversation and get you the result you want. You don't have to worry about simplifying it. You can give any complex prompt. It will break down and do the conversation internally and finally give you the output. And in between, if it requires any input, it will ask you the prompt wherein you can respond whether you want to proceed or you want to terminate. Thank you.